Hi, this is Brian Grant. Hopefully you enjoyed the demo of our WYSIWYG UI over GitOps with our Backstage plugin built on top of our package orchestrator, leveraging the concept of configuration as data to automate changes to the configuration in Git. I'm going to go a little bit more under the covers in this video and show you a prototype that we actually built to figure out the concepts we needed in the package orchestrator. The prototype can also be a little bit of a North Star to show what we could do with the Backstage plugin. It was built in only a few weeks by a few people, but it does have more features than are currently in the Backstage plugin. And I'll show a little bit about what's going on under the hood as well. So in the Backstage demo, I showed creating a blueprint entirely from scratch and then populating resources and editing the kept file. What we supported in the prototype was a flow where we could actually derive blueprints from other blueprints. And I expect there will be a number of cases where people want to do that. So we built this with a vanilla REST backend and an Angular front end. And that we had a little bit more freedom and we're a little bit more familiar with Angular. So actually, the experience you'll see, I think, in some cases is better than what we currently have in the Backstage UI. But here we have a repo of namespace blueprints registered. And this is our base blueprint. And like in the Backstage UI, we can introspect. Here's the kept file, the namespace, and a role binding. And we can flip between the form view and the YAML view if we like. But I'll just stick with the form view for the most part. We can also see the versions here, and we just have one version of this base namespace because I copied it from another repo. So what I'll do is I'll go ahead and create a blueprint from that base blueprint for Istio backends. So I'll call it the Istio namespace blueprint, and this will be a namespace that enables Istio sidecars. And this prototype wasn't quite as optimized as porch is, so it takes a little bit longer to run the render step. Okay, so here we have the blueprint, and it's still abstract. The namespace still says, has a name example. In order to inject Istio sidecars, we'll actually follow the documentation, and it says here that we need to add this Istio injection label to the namespace. So we'll go ahead and do that. And this shows we can actually edit resources as well as create them from scratch. So I'll add this Istio injection enabled label here. And I'll also add a resource, say a limit range, because that's a type of customization you may want to do. So we'll add container limits, 1 CPU and 1 gig of memory, say. And here we show the YAML on the side. Again, we could just show the form view and hide the YAML as we do in the Backstage demo. Some people like the ability to open a panel to see the YAML if they're familiar with the Kubernetes YAML. So that's a feature we could add if enough people want that. All right. So we can go ahead and create this blueprint. And in the prototype, we actually had this persona selector to show that different people can be involved. We're missing one of the personas, but anyway, I'll go ahead and create this blueprint. All right, and now this shows up in the list of blueprints, and this little arrow means there's an outstanding proposal with respect to that blueprint. So I can just select this to open it up, and like in the Backstage UI, I can introspect it right here. I can see the label added to the namespace. Now we don't have a diff view here, but I will show you the diff view we have later. I can see the limit range that was added, and I can actually link out to the pull request and take a look at that. So here, if I want to review the pull request through my Git providers code review interface, I can do that. So here I can see the limit range that was added. I can see the label that was added to the namespace. And I can either merge the pull request here, or I can do it here. And I can say LGTM, and that actually is a comment that gets posted back to the pull request. And we can see here that it's already merged. And there's my looks good to me. Now, in the Backstage UI, we didn't, and in Porch, we don't actually create the pull request. And I actually think we don't want to go this direction. It would require integrating with every different Git provider. Flex project does have a Go Git providers project with interfaces to different providers, GitHub, GitLab, Bitbucket, and so on. But what we found is if we're completely automating the configuration in the repo and the workflow associated with making changes to the configuration, then Git is not actually adding significant value. In fact, in many cases, it was getting in our way. So we actually want to add support for container images, which is a trend that's happening. They can be versioned similarly to Git. There's a container registry available in every cluster. The package, the metadata that the container registry has is actually useful for package management. So if we go that direction, there won't be pull requests anyway. So probably I wouldn't implement that feature, but we'll see. Okay, so here we have, this blueprint available now, and we can look at it. There's just the prototype, created a couple of commits, so they show up here in the versions list. But we'll go ahead and create a namespace from that, and that shows up here in the list. We elided the base namespace because we didn't expect to deploy directly from it, so the prototype supported an annotation on that to hide it from this list. And we will just call this backend 1. This is an app. This is a namespace for app backend 1. All right. And we'll go ahead and create this. And again, this is doing a get and a render. We can see that the namespace is set to the name of the package again, like in the previous demo. Now, the namespace fields are set to backend 1 as well. So one thing we didn't do here is automatically set the role binding. So this is just to show that we could also allow edits by hand here to customize this. We actually had a feature where we could automatically flag any occurrences of the example string, so that would direct someone's attention that something needed to be changed here. But you could imagine it's applying, ordinary UX techniques to kind of provide step-by-step guidance or to steer users towards the most important things to change in the deployment. So you can kind of make the experience as opinionated as you want, but we will just edit it by hand here. So I'll just say backend 1, just to show that that is also possible. Now, we can further customize the experience from the original blueprint. So, for example, we can change the limit range to 4 CPU and 4 gigs of RAM if we wanted to. Now, the platform admin could apply some sort of validation function to impose some limits on these. And then that could flash up, a warning if the validation failed on render that you weren't allowed to do that. We can also add additional resources potentially here if we needed to. But for now, I will just go ahead and create this namespace. And again, it shows up here with the little arrow showing that there's a change. And we can review, these resources and you can imagine seeing the diffs and what has changed here. Or you can look at the pull request. I'll just go ahead and approve this and say, looks good to me. Now I'll go ahead and create 2 more namespaces from the same blueprint back into namespace for app backend 2, and I would just only customize the role binding because that needs to be updated. If we want to update that, and now we made the workflow the same, but again, the workflow is pretty straightforward to change. We could automate approvals with additional validation functions, or if we prevented certain kinds of edits, we could auto-approve in that case potentially as well. I'll just kind of manually approve it here and create one more, because I'm going to show how upgrades could work. So this will be back in 3, back in 3, app namespace for app backend 3. And edit role binding. That really shows the benefit of automatically setting that, though. All right. Okay, so now we're going to have 3 namespaces once I approve this. Approve. Looks good to me. All right, error was gone. Now I'm going to actually update this blueprint. So I can click Edit here, and not changing anything there. All right, so I am going to make some tweaks. I can add an annotation to the namespace, for example. Just add a network type annotation and say, we just want to identify this namespace as part of the service mesh. And there's a diff. And I will add a resource quota. I will add memory limits and CPU limits, so 10 CPU and 10 gig, say, and go ahead and save that. All right, And here we do show the diffs, so I can actually take a look at that. And this is showing it with the YAML view because we didn't get around to implementing it in the form view, but we could do it in the form view as well. This just uses stock diff library. All right, so we'll go ahead and update that. And again, there is a pull request, and that could be reviewed either in the UI. Although we don't have the diff view there. Here it is. Here's the diff view. So we could review it either in the UI or through GitHub, but I'll just approve this change. And what's going to happen now is because we have information about the versions available in the backend's API, the front end can immediately notice that, hey, there is actually an upgrade available. So we see here this upgrade available feature lights up. So we can select that, and it will tell me that there is an upgrade available. And I can take a look at what the differences are. That's just the version update. I can see that this network type annotation will get added, and this resource quota will get added. So I'm going to go ahead and do that. Now we use the same workflow for upgrade. I mean, again, we could potentially change the workflow, but what this is doing is creating a pull request that contains the merged content. So here we see the little arrow, and we can review those differences. Right here, it's the resource quota. Note that my limit range change has not been clobbered. So I overrided this from the base blueprint, and that did not get clobbered. The namespace change was merged, my local change was not clobbered, and the resource quota was added. So that's pretty cool. So we'll go ahead and approve that. Looks good to me. And now I'll be at the latest version, so the upgrade went away, and I can see I'm at Blueprint version 2, and my version is 2. So now I see that new version here in the list. And I'll show undoing that upgrade in a minute by just clicking restore, just like restoring a previous version of a document effectively. But these other two, I'm going to show a feature where the platform team may actually want to push an upgrade to all the downstream consumers of a blueprint. So here we can see, we have 2 more blueprints that are at an older version, were derived from an older version of this blueprint. So we're actually going to create pull requests for upgrading each one of those. And in this model, the owners of those namespaces could potentially, merge those, review them, and merge them when it's convenient. But again, multiple workflows could be implemented there. So we'll see now these both have pull requests open with similar diffs. So I'll go ahead and LGTM those. And now everything should be updated to the latest version. And I can see that right here in this view. All of these are at a new version, and they're all at Blueprint version 2, which is the latest version of that blueprint. Now, so if something went wrong and I wanted to actually undo that, I could say, no, I actually want to restore to what I had before. And, maybe there's some kind of problem. And actually, I can see what that is undoing. It's removing that annotation. We didn't show the resource code object disappearing here, but, that could do that as well. I'll go ahead and approve that. Looks good to me. And now this knows that it is back derived from Blueprint version 1. See, it says, I have a new version for this deployment package, but it's derived from Blueprint version 1. So now upgrade available pops up here again. So, if the problem was caused by some change I made locally, I could go adjust my local version and commit a new version and then opt into the upgrade. Or, if something needed to be changed in the blueprint, you could make another change to that blueprint and then upgrade from that latest version. So additionally, we have more complete lifecycle features here, so we can delete these right from the UI as well. And now again, this is just going through the same process. You don't want people to accidentally delete things in production, so it's probably a good thing. So we actually have a pull request that deletes the deployment. And so all these are going to be gone. So this will just be cleaning these up, and I'll just delete all of them. Now I do have GitOps wired up in the background. I'm not showing the cluster states, but we do have config sync syncing these things in the background. And whether we want to sync at the package level or the repo level is probably we'll want to support both of those options. So, and I'll go ahead and delete this one. Now, one thing I would like to show is how the edits through the UI work. So kept works by applying, transforms configuration by applying what we call KRM functions. And those KRM functions have a standard input-output formats called the resource list. And this is an example of a resource list. So kept function source takes the resource files on disks and linearizes them into a single resource list that itself is a KRM type. And the kept file also uses the Kubernetes resource representation, so we include that here as well. So we have the kept file, the limit range, the namespace, the role binding here in this list. And kept functions such as the set namespace function operate on that list. So here this just looks at every resource and it has a metadata.namespace field. It changes the namespace value to what we said, which in this case is the name of the package. The UI works on this representation as well. It actually gets the resource list from the back end, in this case the prototype, or the Backstage UI from Porch. It can select out the objects it wants to operate on, or it can add new objects to the list. And then when it sends it back to the backend effectively does a kept function sync to write it back to the file system in the same structure. Here we elided the annotations that keep track of the file paths, but there's some bookkeeping information that we maintain in the backend to map these resources back to the file paths. And that is what makes it really feasible to implement the WYSIWYG UI in a pretty standard way. It doesn't have to deal with templates, it doesn't have to deal with a file system, it doesn't directly do Git operations. All of those things are, we don't even have templates, but the running the functions and interacting with the file system and interacting with Git, those are all things that are done by the backend. So when we add support for more storage layers like container images, that is all abstracted away, and the front end doesn't even have to know about it, which is really nice. So, hopefully this was useful in helping you see what's possible with this kind of approach. These other operations we can implement in Porch and in Backstage as well. It's actually way easier to do these operations through the UI than to do them manually in the command line. So I'm just doing it here so I don't have to write a script to remove files, commit, push, remove tags locally, push tags, delete tags from the origin, etc. All that is just taken care of for me. We actually also showed that we can implement additional resource types. So here we actually have a CIS benchmark bundle that applies a number of pod security policies using Gatekeeper. So I can take a look at those and see what enforcement action they have, what other parameters they have. Again, in a nice form view for the most part. You can see here, this matches all objects. We have some descriptions of what these things do. And I can browse the contents of this package, and if I want to deploy that, I can do that. I don't have a deployment from that, but or if I needed to edit it and change policies or add new policies, gatekeeper constraints in this case, it's really easy to do. So we actually found this to be a very extensible approach. We just need to implement new form viewers and editors for additional resource types so we can make that pluggable. And then with that approach, we can implement new scenarios. We just have to create a repo for the types of blueprints we want, and we are off to the races. So anyway, that's about all I have for this demo. Hopefully it is useful to understand kind of the direction we're going and what's possible. If you want to get involved, see the contact page on kep.dev. Hope to hear from you. Thanks. Bye.